Hey guys, I am also available on Unacademy as Nurul Huda and the link is given in the description. You can follow me there for the basics of chemistry and also I'll be solving questions of CSIR June 2018 exam. So see you there on Unacademy and right now let's continue with the video.
Hello everyone and welcome to the channel. Today in this video we are going to discuss about 31p NMR spectroscopy or phosphorus NMR spectroscopy. So why this topic is so important, why I am taking this topic in this video, because if you take out the paper of CSIR net exam, you will see that in past 3-4 examination the questions have been asked from here. All right, like 31p NMR spectroscopy question they are asking frequently from here. So this topic becomes very important and very like this is very easy also, so that's why I'm taking this topic so that you won't miss the questions from here. And one more thing I'm going to tell you that this topic is important because like see the major weightage on the CSIR net exam, the very vast, like one of the very important topic for CSIR net examination is NMR spectroscopy. Lots of weightage have been put on this and many marks are like questions from of many marks are coming from NMR spectroscopy. So it's very important to cover the complete topic. So this basically this topic comes under inorganic NMR spectroscopy. And one more thing, that you don't need many like much of theoretical knowledge of it, or you don't need so much of theory of it. All right, just practice the questions, and questions are quite similar only which have been asked, and like one or two formulas are enough for you to understand and to solve the questions. So without wasting much time, I'll go into the questions and I'll just solve the questions which have been asked in previous few years. Now before solving the questions, I will like to request you all that if you haven't subscribed the channel, please subscribe it, and so that like your subscriptions give me more motivation to make good videos. All right, so let's start the video. Let's start solving the questions. All right, so let's talk about this question, and it came in December 2016 exam. And see, this question looks quite typical because the question says that the reaction between Pi3 and PSCl3 and zinc powder gives P3I5 as one of the product. The solution state 31p NMR spectrum of P3I5 shows a doublet at 98 ppm and a triplet at chemical shift of 102. The correct structure of P3I5 is. Now see, the question seems to be very difficult, and like many people like leave this question while reading only. They think that this much value who will remember. All right, so I will just tell you few things before solving this question so that it become easier for you to understand. See, first of all, for 31p NMR, the main thing which you should know is that the I value for it. All right, so the multiplicity for this. So the value of I for this is 1 by 2, similar to the proton. Like for proton NMR also, the value of I is 1 by 2 there also. All right, so you don't have to remember many you just need to know that this is similar to proton NMR in case of this, means in like when we compare about the I value. Now the next thing is the things are like in NMR spectroscopy, whichever NMR spectroscopy you are talking about, the basic thing is similar, that the splitting will occur, the number of signals will be equal to the number of signal will be equal to the type of species. All right, so please pardon my handwriting, that's not that good, I know. All right, so the number of signal, how many signals you are getting, that will be equal to the type of species, means how many type of the species is, how many different type of that species is. And one more formula you have to know, that the splitting pattern, to find out the splitting pattern you need to know this formula 2ni plus 1. Now by knowing all these three things, you will be able to do the questions very easily. Now this question will be very simple for you if when I will explain the. Okay, see what it is saying, that you don't have to worry about the first two lines. All right, so just start from the third line. It says that the solution state of 31p NMR spectrum of P3I5 shows a doublet at this value and a triplet at this value. And one more thing I would like to add here, that like for proton NMR we have delta value from 1 to 10. All right, generally, and for 31p NMR The delta value is from 250 to minus 250. All right, so like you don't have to like remember the values and all. So here it is saying that the delta value is 98 for a doublet, and a triplet the delta value is 102. It means that the signals you are getting is 2. There are 2 signals. So that means the compound that is your P3I5 will contain 2 types of phosphorus. All right, because this point is telling you that the number of signals which you get is equals to the type of species. Here you will having 2 type of species, means 2 types of phosphorus here, because we are studying only phosphorus NMR spectroscopy. So let's check the options and let's try to find out that how many types of phosphorus are in each options. Now in this option, see, this phosphorus is attached to 2 iodine. So let's name it as A. Now in this phosphorus is attached to 2 iodines, and then it is attached to 2 phosphorus, but this was attached to 2 iodine and 1 phosphorus. That means these phosphorus are different from each other. So let's name it as B. Now let's come out to this. Now this phosphorus is attached to a phosphorus and iodine. That means it's a third type of phosphorus. So here you are getting 3 types of phosphorus. It means for this compound you must get 3 signals, which you are not getting. So this cannot be your correct option. Coming to the second option, here also if you'll see, this phosphorus is attached to 2 iodine and 2 phosphorus. That means this is A type of phosphorus. This phosphorus is attached to 2 phosphorus and iodine. So this will be your B type of phosphorus. And this phosphorus is also attached to a phosphorus and iodine, but it is attached with a double bond. All right. So this will be your C type of phosphorus, because the electronic environment for this phosphorus will be different from the electronic environment of this phosphorus. Okay, so A, B and C, 3 will be different. Now coming back to this option, if you will see, this phosphorus is attached to 2 iodines and a phosphorus. That means it's A type of phosphorus. Let's name it as A. Now this phosphorus is attached to 2 different phosphorus and iodine, so it is different from previous one, so it will be B. Now this phosphorus is similar to the first one because it is also attached to 2 iodine and a phosphorus, so we can name it as A. So here you are getting only 2 type of species, 2 type of phosphorus. That means you'll get 2 signals in this option. So this is the probable answer. All right, so we haven't checked the fourth one, so let's check it and then come back to here. So here this phosphorus is different because it is attached to iodine and a phosphorus. Now this phosphorus is different from the previous one, and this will be different from the other 2. So here you are getting 3 different phosphorus. That's why this will be like, here are 3 type of phosphorus. It means you will get 3 signals here, but in the question you are getting just 2 signals. So that means the correct option for this question will be option number 3. Okay, so see how simple the question was. You just needed to know, find out the type of phosphorus, and that's all. You will be able to do the question easily. Okay, so this in this like that you can easily get 4 marks in December 2016. Let's take the next question. Okay, so let's talk about this question. It was asked in June 2016, and the question says that the number of lines shown by BH3 part of the molecule PH3P, like BH3, alright, so it's given 11, that is the B11 isomer of this, B11 isotope of boron. Alright, so it's asked that what will be the NMR shown by BH3 part of it in the proton NMR and B11 NMR. Now see, this is like different from phosphorus NMR, but the thing is same. Like here the 31P NMR is not asked, but the things will be same only. So I am just taking this question so that like I am explaining it, so that's why I have taken this question also. See, first of all you need to know the structure of the molecule. So your PH3P will be like this. So 3 PH molecule means 3 phenyl molecules will be attached to the phosphorus, then boron, and 3 hydrogens with this boron. Alright, so this will be the structure of the molecule, somewhat like this. Now they have asked you that what will be your what will be the splitting. Alright, so in order to find out the splitting, you need to know the formula, that one formula only, 2Ni plus 1. So this formula we will use to find out. Now first let's talk about boron. So in order to find out for boron, so splitting in 11B NMR. So in this case what will happen, See, boron is attached to 3 hydrogens. So splitting due to hydrogens will be 2 into n will be 3 because we have 3 hydrogens, and I value for hydrogen is 1 by 2 plus 1. So this will be caused, this splitting will be caused due to hydrogen. Now boron is also attached to, directly attached to phosphorus, and this phosphorus will also cause splitting in boron. So that's why this will also get multiplied with it. So 2 into, we have 1 phosphorus, so that's why 1, and the value of I for phosphorus is 1 by 2 and plus 1. So overall splitting will be product of this and this. So just solve it. So you will get 3 plus 1 into, when you will solve it, you will get 1 plus 1. So you will get 4 into 2, that is 8. So in boron NMR spectra, you will get 8. So 8 you are getting into options, either in option 1 or in option 2. Okay, so let's talk about the proton NMR. Now, when you talk about the proton NMR, as you can see, this proton, any of the, all the 3 protons are first of all equivalent, because all the 3 are the 3 will be experiencing same electronic environment, so that's why they are equivalent. Now, you just take any one of them, so it is directly attached to a boron. So splitting of like for 1H NMR, let's try to find out. So it will be 2 into, how many borons are there? There is just one boron, all right, and the value of I for boron is given, that is 3 by 2. So 3 by 2 and plus 1. So this is caused due to boron. Now the splitting will also be caused due to phosphorus, because the J coupling occurs by like when one bond, like it is 1 and 2 bonds away from it, so then also it can cause J coupling. So J coupling occurs till 2 bonds, difference of 2 bonds. So that's why this phosphorus will also try to split the NMR spectra of it. So the contribution of phosphorus will also be seen here. So how many phosphorus are there? One phosphorus is there, and I value is 1 by 2 and plus 1. So when you will solve this, you will get how much? You will get 3 plus 1, and here you will get 1 plus 1. So that means you will get 4 into 2, that is 8. So 8 due to proton NMR and 8 due to boron NMR. So the correct option will be option number first. Okay, so the correct option is option number 1. See how simple the questions are. Just you need to know this formula, and just you need to know the concept of J coupling. So you should know this thing, that J coupling occurs when the molecules are directly attached, or if they are present at the difference of 1 and 2 bonds. Okay. Alright, so let's solve this question from June 2017 exam, and it came for 4 marks. The question says that the 31p NMR spectrum of 2266 N4P4Cl4 NMe2 whole 4. Alright, so now you have a phosphorus over here, and they are asking you that how many splitting you will get, or what you are expecting to get in the 31p NM. First of all, let's draw the structure of it. So the structure will look like somewhat like this. Okay, so I'm just drawing it. Alright, so this will be the structure of the compound, like the given compound 2266 N4P4Cl4 NMe2 whole 4. Okay, so this will be the structure. Now they are asking you about the 31p NMR. Now what you have to see here is, first of all, that how many types of phosphorus are here. So if you see that this phosphorus and this phosphorus both are same, so both will show same type of signal. So that means we can label it as A. So I have labeled it at A. Alright, similarly this phosphorus and this phosphorus both are same, because the electronic environment for both of them is same, so that's why I am labeling them as B. So now we have two type of phosphorus, that means we get two type of signal. So the two could be either two triplets, two doublets, one doublet and one triplet, or one quadret and one doublet. So two signals in the four options it is given. So our structure is like, we can confirm that okay, we have drawn somewhat correct structure. Now let's talk about the splitting. Now when we talk about splitting, as I already told you that the splitting can occur because of 2J coupling. 2J coupling, what I was talking earlier in the previous example, the coupling which was caused because of 2 bond gap. Okay, so this phosphorus can couple because of this phosphorus, because it is present at 1 and 2. 2 bond gap, and this phosphorus also, because it is also present at 1 and 2. So because of these two phosphorus, the splitting will occur in this phosphorus. So the splitting will follow the formula of 2Ni plus 1. So if I put the values, so 2 into N is 2, because we have two phosphorus which are causing the splitting. Value of I for phosphorus is 1 by 2 and plus 1. So if I solve it, so I will get 3. So I will get a triplet because of this phosphorus. This phosphorus will show a triplet here. Now again, when I talk about this phosphorus, this will also show like 2J coupling because of this phosphorus and because of this phosphorus. So once again I will use the same formula, that is 2Ni plus 1, and if I solve it, so it will be 2 into 2 into 1 by 2 plus 1, and I will again get a 3. So the phosphorus of type A will also give you a triplet, and the phosphorus of type B will also give you a triplet. So that means you will get two triplets in this compound. Alright, so the correct option for this question will be option number 1, that is 2 triplets. Okay, see how easy the question was, and it came for 4 marks in June 2017. But in order to answer this question, the basic thing which you should know is the structure of this phosphazine. So phosphazine is a topic which is covered in like main group elements syllabus. All right, in the syllabus it is given as a main group elements. So when you study about p block elements, there you will cover this phosphazine and all these things. All right, so you should know the structure of this compound, then only you would be able to solve the you will be able to do this question. Okay, so let's take one more last question. Alright, so let's solve this last question, which was asked in December 2017, and this question also came for 4 marks and it confused a lot. Many people did it wrong, so I'll try to solve it easily for you so that you will be able to solve it. Is like if it comes further, you will be not losing marks over it. Okay, so the question says that assuming the coupling of pH is greater than the coupling of BH. Alright, oh sorry, it's PB written. Okay, so it's given that the coupling of pH is greater than coupling of PB. Okay, so the printer was like, the font are so small that it's not, that didn't pick it up properly, but it's PB over here and it's pH over here. Okay, so this one was pH and this is PB. The expected 31p NMR spectrum of this for this molecule will be, and it's given that for boron we have I value 3 by 2. And for phosphorus you know that it's 1 by 2. Now you are given with the signals here. Now you have given the you have been given with the signals. All right, so you have to tell that which type of signal you will get over here. Now first of all, let's draw the structure of molecule. The structure of molecule is like PH3. That means 3 hydrogens are attached to this phosphorus like this, and then we have boron attached, and then 3 chlorines are attached to boron. Okay, so the structure looks like somewhat like this. Now see what will happen to this phosphorus. The splitting will occur due to two things, because it is attached to hydrogen also, which is also NMR active, and then boron also, which is also NMR active. So both will cause splitting, but it's given that the J of pH means the coupling of pH is greater. So that's why first the splitting will occur because of hydrogen, and then further the splitting will occur because of boron. First of all, let's check that how many lines it will split because of hydrogen. So for that we will use the simple formula 2Ni plus 1. So we'll use that formula. So 2 into the value of N. How many hydrogens are here? We have 3 hydrogens. So 3, and value of I for hydrogen is 1 by 2 plus 1. So you will get 3 plus 1 is 4. So you will get a quartet. Alright, so quartet. So you will get a quartet, and by the Pascal law, by the Pascal's triangle, you know that if I value is 1 by 2, for I value 1 by 2, and if you are getting a quartet, the ratio will be 1 ratio 3 ratio 3 ratio 1. This thing is the basics of NMR spectroscopy, and if you don't know all these things, I will suggest you to read that Pavia. Alright, the book written by Pavia, Modern Spectroscopy, somewhat now the name of book is like that. I have already suggested it in my video where I have discussed about the books which you should follow. So that book, in that book, these things are given in very detail. So the I value is if the I value is 1 by 2, then and if you are getting a quadrate, then the ratio will be 1 ratio 3 ratio 3 ratio 1. That means the splitting will occur in some way like this. So you will get a splitting into four things. The ratio will be 1 for it, 3 for it, 3 for it, and 1 for it. It means if the splitting would, the signal will look like this, as like this, it will be 3 times of this, then again this and this. All right, so it will look somewhat like this. All the distances, these distance will be same. Okay, and this intensity of this peak will be 3, this peak will be 3 times greater than this peak. So this will be 1 ratio 3 ratio 3 ratio 1. Now this is the thing which is done by proton. The hydrogen has done all these things. Now the next splitting will take place because of the boron. Now how many terms, in how many terms the boron will split it? So again we will use this formula 2Ni plus 1. So we'll give you 2 into, now how many borons we have? 1 boron, and I value is 3 by 2 and plus 1. So we will get how many? 4. Now again we get a quartet. Now again quartet is obtained, but here I value is 3 by 2, it's not 1 by 2. Therefore the Pascal's triangle, the value of from the Pascal triangle you cannot use here. That means the intensity will not be 1 ratio 3 ratio 3 ratio 1, but the intensity will be 1 ratio 1 ratio, means the ratio will be 1. Okay, so this value you should know. If you don't know this value, then also see how I will tell you how to do this question. Now till now you knew that the splitting will be occur into 4 parts from the first part. From solving this much only, you came to know that the splitting will occur in 4 parts. Now here the splitting has occurred in 2 parts only, and here also it's occurred in 2 parts. So these options are not correct. Okay, so by the first part of question only, solving the first part, you came to know that these options are wrong. Now among these two, one could be the correct option. All right, so now see that it is given that okay, the intensity of this and this will be 1 ratio 3 ratio 3 ratio 1. That is in both of the case. But now what will happen, this boron will split these signals further into 4 parts of same intensity. Now if it would be like, if you don't know anything, okay, if you don't know about this ratio, then how to do this question? So it tells that it is split into 4 parts. Here also it is split into 4 parts, and here also it is split into 4 parts. But here the splitted signals are in ratio 1 ratio 3 ratio 3 ratio 1. That means the complete signal due to pH also split into 1 ratio 3 ratio 3 ratio 1, and due to boron also it is split into 1 ratio 3 ratio 3 ratio 1. That means it could only possible if both I values are same. If for boron also the value would be 1 by 2, then it would be same, because like then only Pascal's law would have followed, and here you would have got 1 ratio 3 ratio 3 ratio 1. But it's not like that, it's 3 by 2. So that's why this option get eliminated here. All right, so this was like a hit and trial method, but if you know the value, then it is well and good. So that means the signal will further split into 4 signals of equal intensities. So what you will get, you will get a signal like this. See, all the 4 intensities here are equal. Here also all the 4 are equal, all the 4 are equal, and all 4 are equal. So what has happened, the boron has just splitted this signal into 4 signals of equal intensities. So that's why the correct option for this question came to be option number 3. Okay, so I hope till now you have understood that how to do the questions from 31p NMR. If you will try this type of concept only for fluorine NMR also, then you will be able to do the questions there also. Okay, because for fluorine also I value is 1 by 2, and it's very easy to do questions from there also. I will try to cover them in my one more video. Okay, so I have made this video because you were asking, few people were asking me to make the videos for here. So what will be the splitting pattern over here? So splitting pattern will be like somewhat like this. Okay, so 1 ratio 3 ratio 3 ratio 1, again it will split into 4, okay, of equal intensity. So this will be your final splitting value. So this intensity will be 1:1 ratio. Okay, so that's all. So this was that's all for this video, and I hope you people understand all the things well. If you want to ask anything, you can ask in the comment section. And one more thing, do follow me on Unacademy, because I am posting videos over there. I'm solving questions from your CSIR net June 2018 exam. So you can follow me there, and like it will be good for you guys. Thank you for watching. Thank you.